Hello everyone. We are going to start Intro to GitHub soon. Just going to wait a minute for people to pile in and we'll go from there. Okay, here. Let's get this going. Here we go. Okay. What's going on, everyone? Gatsky D, hello. Paradin, and Thinkverse. Welcome, guys. Thanks for coming. Let's go ahead and bring things to let's get things going soon. Okay, so this is going to be Intro to GitHub. With that, we have some nice slides for you guys. Walk us through, help us with these most fundamental concepts. So hello. Lots of people pouring in. I like that. Good stuff. So who here is familiar with GitHub? Have any of you used it before? Are you an avid user? Do you only know the fundamentals, or is it just something completely new to you? Hello. Good morning. Good evening. Good wherever you are. Just started using it. Okay, sweet. Okay, so you guys have a little bit of experience with that, at the very least. Okay, supposed to be using GitHub for class, struggle with Maven and testing repos. Okay, maybe we could talk about that a little bit later on, in fact. Yes, definitely. Relearning the basics and putting together, just kind of coming into contact with the fundamentals again certainly helps. Even putting these presentations together helps me quite a bit. Started during your last hackathon. There we go. It's always a good place to get started with anything. Used GitHub. Cool. Yeah, so we have people with all sorts of different levels of exposure to GitHub. Yes, Git is definitely a star tool when it comes to GitHub, if not the star. Definitely takes a little bit of practice. I have a Git cheat sheet that I keep handy whenever I have to use it. I don't use Git like every single day, but I use it enough to where I have to keep refreshing myself on it. Let's say that. Not too rare, those sorts of situations. To know how it will be different in work settings. We'll definitely go over that. Part of this presentation is going to cover Git and GitHub as a collaborative tool, which is one of the main ways that it shines. So definitely very, very important to have a grasp on GitHub whenever you want to work with others, which is going to be in basically every notable position that involves programming in public life or in any sort of career. Hello. Data analysis. Muted. I think everyone else can hear me okay. You guys hear me all right? Okay, good. I've had tech issues before, so don't mind jumping into them. Okay, looks like the audio is good. Okay, perfect. Okay, great. So with this, let's just jump into our intro to GitHub. Okay, so first we have to ask the question, what is GitHub? GitHub is a web-based platform and a service for version control and collaborative software development. You can see we have all these different aspects that really anyone that goes on to interface with GitHub eventually learns. Version control, repositories, collaboration, branching, merging, so on and so forth. We're going to go into detail on these throughout this presentation, and give you guys the in-depth lay of the land with all of that. So, and yeah, it's kind of crazy because talking about a tiny bit before, it's such a crucial part of being a developer nowadays. But for example, people in I don't know, I've heard stories of people going through school and like basically never getting their hands dirty with GitHub, which is really a shame. It's such a fundamental technology that'll help you out in all sorts of different ways. But let's go through this list a little bit, give you a bit of detail on everything. So first, version control. GitHub is primarily used for version control, which is the practice of tracking and managing changes to software code over time. It allows developers to work on projects without interfering with each other's work. It provides a history of changes, making it easier to understand and fix issues. Repositories. In GitHub, code is organized into repositories, which we'll be taking a look at in a little bit. Repository is a collection of files and directories, along with the version control or along with the version history of those files. It can be public, allowing anyone to view and contribute to the code, or private, which restricts access to a select group of collaborators. In fact, let me see if I can just I don't see why we can't just jump into a repository right now. Let me see what I remember. I showed one last time that everyone seemed to get a kick out of. This little Pokedex app. Pokedex is kind of a standard tutorial project for people learning about APIs, but with this one, I added a few extra features that people were, I guess, that they found interesting enough. But we'll use it to kind of show an example of a repository, just so that everyone kind of gets an idea of what that is, what that looks like. So can I share my screen? Okay, so let's take a look at this. So here we have a GitHub repository. We can see that I have, if I go into my profile, I can see I have all of these different repositories. Again, these are all different projects, all different coding projects. I can click into one, and I see it's like a base for all of these different files. So these are all the different files that are involved with the program that's being developed. As it was talking about, we can see version control, history, where I made all of these different edits to the code. And with those edits, I basically have taken a snapshot of the project. Here, let me show you. Folder. Can I go all the way to the beginning? But essentially, I started with the project, bare bones, nothing in place. So you can see, here's a repository when I first started it up. Much smaller collection of files, not as fleshed out. You can see that I've added more and more feature, more and more code that accomplish more and more features. And from there, it eventually builds all the way up to the full repository as we have it now. But I can go back to all those snapshots. It's kind of the beautiful thing about it. And two, if someone likes this project of mine and they want to develop on it, if they want to add features or change something about it, they can copy this repository, download the code, and they can make their own repository. So I know this is a lot at the moment, but kind of just gives a bit of a taste of how version control manifests itself on GitHub and just what that looks like visually. So we're going to be going more into the concepts and the theory and all that stuff behind it a little bit later on. So anyways, that's repositories. So GitHub is also good for collaboration. GitHub facilitates collaboration by allowing multiple developers to work on the same project. Developers can clone a repository to their local machines, make changes, then push those changes back to the GitHub repository. This makes it easy to work on software development projects as a team. So we had a question about using GitHub for school projects. Let's know how it will be different in work settings. Well, I guess it depends too on like what your school projects are currently like. Is it that you're just putting together little portfolio pieces, doing little examples or tutorial projects, and simply putting them up on GitHub to show that you understand version control? If it's that simple, then being in a real collaborative environment is going to be quite the contrast. And I mean that for the better. So I think it definitely is a lot more rich, and you definitely see the utility a lot more once you're collaborating with other people on a living, breathing project. Go a bit more into branching and merging. Yes, we are definitely going to cover that. So very, very crucial aspects of GitHub. Collaboration with group mates are the works for my school projects. Okay, so it sounds like you're getting a bit of a taste of what it's going to be like in the professional world. We'll talk about too some of the ways that you can start to get experiences that mimic the professional world all the more, like maybe something in line with working on open source projects, or if you get an internship that uses GitHub and version control, which would not surprise me considering it's such a powerful technology. Those would definitely give quite the insight to the next step of GitHub usage. Okay, so talking about collaboration, branching and merging, as we'll cover branching and merging in even more detail later on, but just a bit here. So GitHub supports branching, which allows developers to work on separate features or bug fixes without affecting the main code base. Branches can be created, modified, and merged back into the main code base using pull requests, which enable code review and discussion before integration. So yeah, branching, which essentially allows you to copy the code base, make changes to it, and then implement those changes into the final code base if they are deemed valuable enough. And merging, well, I guess merging would be the implementation back to the code base. But yeah, very, very helpful, very, very powerful concepts. So issue tracking. So GitHub includes an issue tracking system, making it easy to manage and prioritize tasks, bug reports, and feature requests. Issues can be assigned to team members, labeled for categorization, and linked to specific code changes. So again, we can just really see how all of this is built for collaboration at the end of the day. Well, I mean, I guess an individual could use this on their own projects as well, but it really, really gets people on board towards one common goal when you have these sorts of just systems in place that GitHub offers. So community and social coding, GitHub is more than just a version control platform. It is a social network for developers. Developers and teams can follow each other, store and fork repositories, and engage in discussions related to code changes and issues. This fosters a sense of community and knowledge sharing among developers. So with that, it's not just good for collaboration in and of itself, it also fosters an entire community of discussion based around just everything to do with version control and software development and everything that you could possibly want, tackling any sort of project. So again, just very, very powerful stuff. Integration and automation. GitHub supports integration of various third-party tools and services through its extensive API, which allows for automated workflows, continuous integration, and deployment pipelines, which makes it a central hub for the software development lifecycle. And then two, there's also the open source aspect of it. GitHub is widely used for open source projects. And two, good to mention private repositories. The open source aspect and the private repository support ultimately makes it a versatile choice for both public and proprietary software development. Let's see. Got people, lots of activity in the chat. Love it. Does Git or tug of war with all this push and pull? Yes, I know. Very curious terminology at times in software. It makes you wonder I don't know. There's some pretty funny examples of just weird software stuff out of context. But I think that the strangest ones to me are like in JavaScript with manipulating arrays or lists in other programming languages, like push, pop. I don't know. It's just like I always have to remind myself what exactly they mean because it's not exactly intuitive with what their names are. So what kind of coding languages would you recommend learning if looking for a career in UI and UX? So not exactly related to the topic at hand, but while we're on it, I wanted to send this helpful resource that I found recently. UI. Let's see. This is a really great site you should all be aware of called roadmap.sh. And it has these different just roadmaps for how to learn all sorts of areas in software development. So I just posted in the chat this one on the things to understand with UX design at the very least. In terms of programming languages, I'm not too sure off the top of my head. It really depends on what all you want to do. Like I know that one developer tool that's certainly helpful are things like Figma, Balsamic, Sketch, Adobe XD, as it says in this UI design guide. I use Figma and Balsamic myself for front-end work. If you want to do front-end web development, then JavaScript, HTML, CSS, and technologies built from that, like React, are definitely the way to go. But I don't know. You'll have to explore that. I hope that gives some insight at least. Let's see. Details about signed and unsigned commit, since I'm not able to verify my commits. Yes, we will definitely delve into that. Okay. What's full stack? Machine learning developer? Source into. I have to refresh myself on that, honestly. It's been a minute since I've delved into all of that. I don't want to get too off track though. It's good for us to be curious, but definitely jump into GitHub a little bit more. So we kind of covered all these basic aspects of GitHub, or fundamental aspects of it. Let's keep pushing forward. So version control overall, which is kind of the heart behind, how would you say it? It's really the reason why GitHub exists in the first place. So version control, a system that tracks changes to files and directories over time. We kind of saw that indirectly through all of my, or really directly through all of my commits on that one Pokedex project that I showed you guys a couple of minutes ago. So on things to know with version control, we have here history tracking, collaboration, branching and merging, so on and so forth. We can see there's some overlap with we just covered on. I'm getting eaten by the void right now. Hold on. Let me see if I can reposition this. Okay. Anyways, so version control. Crucial tool used in software development, content creation, and various other fields where managing and collaborating on digital files is essential. So as we see, aspects of it to know about. History tracking. Version control systems maintain a detailed history of changes made to files. Each change is associated with metadata, including the author, timestamp, and a description of the modification. This historical record provides a clear timeline of project development. Collaboration, again, allows multiple developers to work on the same project concurrently. Prevents conflicts by allowing each user to create their own branch of the code, make changes independently, and merge their work with the main code base when ready. So, again, very fundamental, like we just talked on last slide. Same with branching and merging. So branches are separate lines of work. you can use for doing things like developing different features, bug fixes, experiments, and you can merge them all back into the main project when they're deemed viable. Let's see. Okay, just keeping up on the chat here. Okay, so conflict resolution. When developers make changes to the same code simultaneously, conflicts may arise. So version control system will allow for, it provides tools to resolve conflicts, ensuring that changes from different sources can be combined harmoniously. So we'll see that in some detail later on too, once we really start picking around in GitHub and different repositories and their version control histories and all of that. Also allows for backup and recovery. Version control acts as a backup system. If a mistake is made or code is accidentally deleted, previous versions can be restored. It's particularly valuable in avoiding data loss. So yeah, as we saw in that repository before with like those 100 plus commits, they you can load the file, you can load the projects from, you can download the code for the project and at any of those points. So documentation, developers can provide descriptive commit messages explaining the purpose of changes. This documentation helps team members understand the history and context of code modifications. Back to here. We're covering some good ground here. We kind of see how this all pops up on this file again. I don't see why not. Here. Oops. Oh. Fighting with the screen share widget. Okay, so as we were talking about, we have the history tracking, which is, I mean, this is on GitHub. Version control can also be on your local machine. It's kind of where it starts usually, but we see it reflected on GitHub, like here in the commits. So as it said, it shows things like the author, myself here, timestamp, you see the date, and a description of the modification. So you can see I put like give some context as to what exactly is, what changes were made. Then for collaboration, multiple developers, that is not the case with this one. Branching and merging. I don't think I made any, no. Oh, 2 branches, okay. So usually with branches, what you'll do is when you develop a new feature, you'll copy the code base and you'll copy it for like a particular reason. Like, okay, I want to implement this new feature, or I want to experiment with changing the UI, or I want to, whatever it is. You kind of have one singular task typically in the most simplified example. And from there, you make your changes. So here I made a branch for testing the deployment of the website, of this little website here that I developed. And with the deployment, I don't think I got it working in the end, actually. Then I moved on to other things. But let's say I got the deployment working. It's all good. I'd say, okay, well, everything's working on this branch. If everything completely broke and I completely messed up the code base, then I'm not in trouble because all I did was copy the code base. I'm working on a copy of it. My main code base here is completely untouched because I made a copy, right? That's part of why we make branches in the first place. So I do my branch. If it's completely broken beyond repair, I can do whatever I want with it. If it's good, the changes that I make, if everything's viable to add back to the main project, then I can merge this branch. I can merge its code back into the main. And upon doing that, I will have, I'll just contribute more to its history of the changes made. So then usually once you're done with making a branch, then you can just delete it because everything's done that you had on it. So hope that gives some additional insight on all of that. We talked about documentation. As you saw, I had the different commit messages on, let's go back into here. My different commit messages that I added. There's also, well, I was going to delve into the README, but that's a little bit different in terms of this meaning of documentation in this context. So code review, well, here. I think that kind of paints the full picture there. Jump back to the slides. So we have code review. Version control systems often include features for code review, allowing developers to comment on and discuss proposed changes before they are integrated into the main code base. So GitHub also allows that itself, but we'll go into that. So security and access control, version control systems offer access control mechanisms. Repository owners can control who can view, modify, or merge code, ensuring data security and compliance with organizational policies. So you don't want just anyone coming onto your repository and changing things willy-nilly. Not usually the case. So you can just safeguard against tomfoolery and shenanigans, you could say, against that. So traceability, version control enables traceability of changes, which can be essential for auditing, compliance, and project management. So in terms of the various version control systems available, Git has become the most popular version control system due to its speed, flexibility, and strong support for distributed development. So there do exist different version control systems, but Git is kind of the omnipresent one that everyone knows about. And it's in the name too, GitHub, the hub for Git. Version control overall is a fundamental tool in modern software development, helping teams manage complex projects, collaborate efficiently, and maintain the integrity of their code base. Let's see. Okay, just keeping up with the chat here. Create a new branch to keep main clean and untouched, then test with the new branch. Main is still intact. Yes, that is super, super important aspect of the workflow. I believe all repos that have issues to be resolved should have a prerequisite markdown file, which clearly states the skills and experience the person needs, plus the code base stack library that is being used. Yes, that is, there's a few different ways to accomplish that. Let's delve into this little project here again. I don't think I have any issues on it. No, we can go to another project to kind of show this. Here, let's do this. So one of the projects that I used last time, this isn't mine. I don't really know anything about it, really, just a random one that I grabbed. This is Pokemon Red Experiments. Playing Pokemon Red with reinforcement learning. So here in the markdown, we do have person needs plus code base stack library that is being used. Yeah, usually like a good README file, will have information like the technologies being used and at least giving context in terms of the tooling and the like for the software. So, and two, you can kind of just tell also from the code in and of itself. If you kind of poke around, it's not as explicit as just like having a README put together that outlines everything. But I think like in mine, let me see. So it tells you a little bit about what it's doing, sort of the features of the app, and two, like here in my README, I put what exactly was used to create the app. So definitely helpful for newcomers hopping in. But in terms of this one, which actually has some active issues, or at least, yeah, that was my branching of it. Let's go to here. I guess it depends on the person putting together the issues and how much information they want to put into it. But let's see. Some issues will be flagged with things like good for first timers or good for first commits, like people that are just starting with GitHub or with the GitHub workflow, with collaborating on open source projects, so on and so forth. We'll kind of see that as we go throughout this presentation. But I'd say in a decently well put together repository with issues that are open for, that like are encouraging the developer community to contribute to it, they at least take some steps to communicate such things. Work with branches also leads to fewer conflicts when more than one person is working on a project. Yes, vital. Here's done with a contributing .markdown file that some repo suggests as required reading before contributing to a project. Yeah, very good point as well. Again, for very well put together projects, they usually anticipate these things and have a good resource for exactly that. So just have to kind of hope that they're feeling generous with outlining for contributors how to best jump into the project, which honestly is in everyone's interest, I would say. But anyways, with that, let's see. Oh, already a half hour in. Wow, time flies. So I have quite a lot in this PowerPoint actually, but we have some good discussion going. Some of these things I don't have to go into too much detail on. Like I have this aspect of the history of GitHub. Honestly, not too crazy to know about, but we'll cover it really quickly. So GitHub, basically its history and its significance are closely intertwined, as its growth and evolution played a significant role in shaping modern software development and collaboration. So it was founded in 2008. It was created as a response to the need for a better platform for version control and collaboration in software development. So there were other version control systems at the time, but they lacked the social and collaborative features that GitHub would introduce. So the developers chose to build the platform on top of Git. Git's speed, efficiency, and branching capabilities made it an ideal foundation for collaborative coding. GitHub quickly gained popularity due to its user-friendly interface, effective code collaboration features, and open source ethos. Its ease of use and the network effect of having a large and active user base contributed to its rapid adoption. So it actively promoted and supported open source projects, which attracted a broad community of developers, including major technology companies and open source foundations, which all significantly contributed to the platform's growth. And to this day, GitHub continues to evolve by introducing new features, integrations, and collaboration tools. The introduction of pull requests revolutionized code review, making it easier for teams to collaborate effectively. So I think all of that kind of paints a good enough picture. A good point here is on developer portfolios and professional identity. GitHub profiles often serve as professional portfolios. Employers and clients often review GitHub profiles to assess developer skills, contributions, and coding style. I know it's certainly the case for me when I applied to places for jobs, for internships, so on and so forth. They explicitly asked for my GitHub profile. And when I do recruitment for a nonprofit that I'm currently at, which I help onboard junior developers for, when I do recruitment, always looking at GitHub profiles. Definitely a major resource. Acquired by Microsoft. Okay, you get the picture now. So key concepts: repositories, commits, branches, pull requests, issues. We've seen a few of these so far as we've talked today. So repository, a fundamental concept in GitHub. It's a storage space for a project's files, including source code, documentation, and other assets. Repositories allow developers to organize, track, and collaborate on a specific project or code base. So we most certainly saw that. And again, just these two little projects that we looked at. So if I can pull, hiccups. If I can pull these both up, we can see we have our repository here. You can see the collection of files for the project and directories. We have folders here that have all the more files inside of them as well. Again, it's the full code base. Jump in and just dive deep into everything within it, as well as the documentation. Like here's the markdown file, the readme.md, which has all of this within it. Blah, blah, blah. Okay. So we have that, documentation, other assets. So again, helps organize, track, collaborate on a specific project or code base. So we have commits, as we saw, represents a specific set of changes to the code. When the developer is satisfied with a set of changes or fixes, they create a commit, which is essentially a snapshot of the code at that moment. We usually accompany commits with a commit message, which just gives context and describes the purpose for any changes. They are very important for, again, context and documentation for the project's history. That way you or someone else can jump in however much time later after the initial changes to the code, and they can understand like not only what was changed, but also why. So again, here we can see our commit history. If we scroll up, 108 commits, and we have all of these different commits here. Again, all these different snapshots after some sort of change in the code. So I can just click into one of these random ones. It'll show the different changes made compared to the code in its previous state to the code as it now, the code in its previous state compared to the changes made that sparked this commit. So that's commits. Then branches we've already seen. Pull requests deals with merging. It's a feature in GitHub that enables developers to propose changes made in one branch and request that those changes be incorporated into another branch, typically the main branch, right? Like we were talking about with my my deployment branch here. My two branches that I have the main branch and I have the deployment tests. And if I get this working, once I come back around to it, or if I want to add a new feature, or like I said, change the UI or whatever it is that I want to do, make a new branch, make those changes, merge it into the main project if it's changes that I made are viable and I want to commit to them, and delete that branch. Issues are a tool for tracking tasks, bug reports, and requests, and feature requests. So we kind of delve into issues a little bit. We didn't really dive into them though. So we can see on this project, there's all these different issues to be addressed. There's something in the code base that could be refined, or that there's a feature that could be added, or there's a bug, something along those lines. So we can jump into, that's a good one. I don't know. None of these are particularly exciting, but they should kind of get the person is having issues with installation. Again, it's kind of a technical one, not something that you can just jump into that makes a nice little example. But I mean, sometimes it can be pretty simple, honestly. Like maybe someone just, I don't know, the silliest stuff it could be. Like something's misspelled even, or maybe there was one value within a feature of the application that is sometimes gets assigned something unviable and makes it crash, so on and so forth. You know, anything that you can conceive of as being an issue. But the thing to know about them is that they, again, I guess the anatomy of an issue, you have your title, description. Usually there's labels in terms of just kind of describing the state of the issue, or like what aspect of the project. Is it UI, UX? Is it something with the code? So on and so forth. You also have assignees. Like, again, because there can be a community of developers working on something. And if you have an issue, you don't want 6 people to work on it independently because it just wasn't organized as to who should do what. So you have the feature of doing assignees. So, and you know, it's just kind of, I don't know, straightforward, common sense project management stuff. But again, very, very useful feature to have, so that you have an infrastructure for managing this and streamlining it. safeguarding against all sorts of possible mistakes. So anyways, these key concepts are the foundation of using GitHub for version control in collaborative software development. They enable effective code management, teamwork, and the organization of tasks and features, making GitHub a powerful platform for modern software development. So I hope I sold you guys on GitHub and version control as a whole in terms of these first things to know about it. If you want to utilize GitHub most effectively, or just have access to all the more features like having your own repositories and making your own changes to things, so on and so forth, definitely set up a GitHub account. So again, we have a lot of, I think, more exciting stuff to talk about as we go through here, but definitely walk through GitHub's website, set up an account for yourself if you don't have one already. And you can even follow along with us once you have this in place. So, just kind of standard stuff for any website. Add a picture, bio. You can have your own repositories. You can contribute to repositories. Just kind of standard stuff, setting up an account on any sort of service. Okay, let me show a little bit on how to use the website overall. Let me just keep up with the chat here. Let's see. Be as descriptive and semantic as possible for commits. Yes, with your commit messages, definitely do not make it a guessing game or for anyone coming to your project trying to understand what exactly is going on. Want to be transparent and as effective in your communication as possible. And yes, here, think first, expanded on that. When creating issues, be sure to add as much information as you can about it. Your app versions, language versions, error messages, and such. That makes it easier for maintainers to solve your issue. Yes, proper communication is needed in everything, honestly. It's so crucial how much time you can save and just how much more efficiency you can manifest by having these sorts of things in place. Because too, it's like if you've already went through if you are creating the issue yourself and you already have an idea of like all these different things that may be contributing to the issue, you might as well spell them out, because otherwise someone trying to help you with the issue may eventually just have to know all these things anyways in order to properly help and resolve the issue. And if they're not already there when they're starting to help, it's going to take extra time to try and figure all that stuff out. And just a big headache. Wastes time, makes things more frustrating. Certainly not the way that you want to go. So there's definitely is a proper conduct of communication when delving into these things as well. That is so important as well, because right now we're just kind of talking about just like how to use these things in terms of like what is a repository and what are commits and blah 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 blah. But the proper way to go about utilizing them in terms of like how to most properly communicate with people is arguably even more important than even knowing the tools themselves. It's really crazy. It's like naming your variables, but infinitely more involved. People are all the better for it. Yes, Git and GitHub are key skills, definitely, especially for the professional world, which I'm sure a lot of people are here for. Learning how to be a good developer, for be able to contribute in a meaningful way to the world. Yes, so context, communication. So add steps of taking to try and fix the issue myself. Yes, that's very good. Think first. All that additional context is super helpful. And two, like when you include these things, it makes people want to help you as well, because they see that you've already tried your best you've already put in effort to try and resolve this. which probably means that you've already handled all the goofy little things that it possibly could be that don't, that like, I don't know. I've definitely noticed that a lot with helping people myself and with getting others to help me. If I show that I've put in effort, that I've already handled the most common cases where mistakes could have possibly uh, arisen, people are so much more willing to actually help. Again, it's all about proper communication. It really goes back to this. Exactly, context. So important. So anywho, just kind of see creating a repository. Yeah, I guess there's more of the kind of tutorial side of things. We could jump into that a little bit. So using GitHub's web interface, you can access the user dashboard, explores the repository tabs, activity feed, customize the dashboard, explore and interact. There's a few things that we can do here. Kind of just showing off GitHub as a site as a whole. So let's do this. Is to access the user dashboard. So do I have to be signed in for this? Most likely I do. Considering it's the user dashboard. But not a big deal as right now. Explore the repositories tab. Yeah, I was going to say, I feel like, here we go. Repositories. So we can just, again, GitHub is all about hosting repositories, hosting these different projects. You can even just browse through random repositories if you want. So you can search by topic, trending. We can just do Explorer too. Isn't that nice? All these different projects. See if there's anything that catches us. Innovative superfamily of fonts for code. I guess there has to be a crazy community for fonts. Open source project built in or receiving significant contributions from Brazil. That sounds interesting. I don't usually go on this stuff. Usually just like focused on personal projects and the like, but it's interesting to see what the developer community and the world as a whole has to offer. Challenges. Front end challenges. Open source challenges for companies around the world. Interesting. So yeah, I mean, it's kind of interesting because you'll see, I've seen GitHub used in a few different ways. One is for hosting projects, like coding projects, that's for sure. As we saw with like my little website application, a web app here. But a lot of people will also use it for hosting just resources. Like I know there's that really, let me find this. There's open computer science curriculum on GitHub that I saw the other day. Yeah, here, look at this. So there's this GitHub repository purely on open source society university, path to a free self-taught education in computer science. So you'll have people, again, it's not like there's a coding project or anything here. Instead, it's a resource for pointing people towards how to self-teach themselves in different areas of computer science. So, I mean, I don't know. There's a lot of different uses. Like there's this here. I've seen people do roadmaps, like the one link that I posted for learning different areas of development or different concepts. It doesn't even have to be tech related. I mean, I'm sure you could have a repository teaching all sorts of different things that aren't even remotely interested or related to tech. But you kind of see like people will also use repositories and just the GitHub, philosophy in these different ways. And two, people can come in and they can make contributions to this curriculum as well. I'm sure it's probably things like that here. Missing specialization. I don't know. Let's say there's some issues here. for testing. Right, so there's even, again, like the issues for this one, because it's a course, it's probably not going to be on more technical things. It's going to be about the nature of the curriculum itself. So I don't know. I find this stuff sort of interesting because it's there's all sorts of use cases that you can have. Anyways, yeah, so you can see that we can explore different repositories as we did. Activity feed, customize your dashboard, explore and interact. We'll kind of get the gist behind all that. Let's see, do follow GitHub on YouTube. They release a weekly catch-up video. That's quite cool. Oh, nice. Definitely good to know. But here, let's keep going on. So creating a repository, certainly important. I don't know. Well, are you guys more interested in learning like how to go through these basic steps in terms of like how to get set up on a repository and adding files and such to your own repository? Are you interested more in like learning more about like Git, best practices, so on and so forth? So we have these different resources here. So I know people were talking a bit about like how can you use GitHub for more specific cases. Well, there's also discussion on like how do you use Git in particular. In case anyone has any preferences, I'm willing to dive into both or one or the other, focus a little bit more on. We have quite a bit of material that we can jump into. But in lieu of no response, we'll just keep pushing on. Guess I can sign in. Jump into that. Let's see. So here, let's see if I can share this screen. Obscure Git commands that are really useful. Well, I guess we can cover those. I guess this is intro to GitHub ultimately. So we should at least give a little bit of some of these features here, like creating a repository and the like. It's easy to have fun, get lost with a few things, but we'll definitely talk about Git and some useful commands in a little bit. But let's just make sure that we cover some of these fundamentals too. Okay, so see, I have my logged in, have my repo here, or my my user dashboard overview here of my accounts. So what I want to do is just kind of walk you guys through the basics of using GitHub now. When it comes to making your own repositories, your own projects, so on and so forth. Pretty important thing to understand, at least the basics of. So nothing too crazy in terms of this. What we'll certainly want to do is we can switch over here. We see we're going to look at how to create a new repository, configure it, and just, again, kind of understanding a little bit more about the anatomy of a repository and just kind of how that comes into play with putting your files together and the like. So with that, what you want to do first and foremost is, of course, be into your accounts. You can get to your repositories tab here, and you'll want to click this new button to create a new repository. So with that, excuse me, you want to give your repository a name that should reflect the nature of your project, of course. So I don't know, what can we do? Repo example, why not? Okay, we can put whatever we want on it. This is an example repo. Showcase creation of a repo here on GitHub. Why not? And we kind of mentioned it very briefly a little bit earlier, where you can set the visibility of it. And you can initialize it with a README file, or you can add that yourself at a later point, or you can take this README file and add additional info to it, so on and so forth. Add git ignore. It makes more sense once we work with git, which we'll cover in a little bit. Choosing a license. That is definitely an area in and of itself. But again, I like this this little overview of it. Basically tells others what they can and can't do with your code. So I'm going to go ahead and create this repository. And it's as simple as that, really. So now the only thing with this repository is that there's no code on it, right? I basically have a basket here. I have a place where I can have a project on my computer that I'm developing on my local machine, which I can then push the code to. And from there, I can sync the repository here in GitHub with the folder, the directory on my local machine, which has the code that I want to host, that I want to keep track of, and that I want to put onto the web ultimately with this repository. But this is the first step. But so it's very common for people to use a repository, again, to sync up with a project on their local machine, which you'll then keep updated on GitHub with the changes that they make on their local machine, with the edits to the code that they make. But you can also you can add files and code and make changes and the like to a repository on GitHub itself as well. And I'd say not as common, but certainly is possible. The check-in link. Yes, let's see. Certainly get that for you. Yeah, thanks for making it too. Let's see. I'm gonna snag it from the Discord, in fact. But how's everyone's intro to GitHub so far? In the meantime, hope it's given some insight, or it's shown some different aspects of GitHub as a whole. So here is the event link. Find it here. Okay, so let's jump into this again. So I have my repository. I've created it. Now here, even when I first made it, it's giving me some direction of what I could possibly do. I can link up a project on my local machine to this repository. I can, that's kind of what both of these are outlining essentially. So with that, let's jump into our next slide here with learning how to affect the repository here on GitHub. So we can actually add files. Add and manage files. Again, kind of the whole point of a repository overall. You can see how we can do that here on GitHub. So let's see. Well, I guess too, it'd be helpful to maybe go over a little bit of some best practices and just things to know once you have your repository up, or when you're creating it. For repositories, naming conventions, just good to know. You typically want to use lowercase letters, separate words with hyphens or underscores. And 2, as I said before, choose a name that's relevant and communicates the project and its purpose properly. And avoid spaces, special character names, and the like in your repository name. So you can see I did that. In fact, I didn't even think about it just because I've done this so much. Definitely a good thing to follow with that. And as we were talking about before, we want to give context. on what your project is, what it's all about. Is it going to give me a proper view of this? Probably not until I actually have some code on there. So maybe we'll just get some code in here before we delve more into different aspects of it. But here we can go, we can add some code. Really, there's the add file portion. Unless it wants me to really wants me to link it up with something, that's fine too. So here. Okay, let me pull up that little Pokedex one from before. So code, add file, yeah. It's gonna say, I guess it just really wants you to connect it with something. That's perfectly fine. I'd rather wait until we get into Git for that overall. But essentially, we made a repository. We can link up our Git project with that. We can upload some code, and things will be going. Oh, here we go. Get started by creating a new file. I was gonna say, oh, I hate how stuff like that is tucked away. Thought I was going crazy because I know that usually on here you have your Git file, your add file here, but here it's just this little line here. Let's click on that. So here I have my file. Maybe I can just do a simple text.html where I say hello world. And so in this, so again, this is my currently empty repository. But I clicked on add a new file, create a new file. From there, I can, well, I've made this file, and it's certainly a change to the code base. So with that, I'm going to want to commit this change to the code base that I've made. Right, just like just like in this one little web app project that I have all of these history, like change commits to my project as a whole. Same thing here. Over here, I'm adding a file, so I'm going to be adding a commit to the project history. So create index.html. So adding the first file to my new repo. Once we do that, we can see, oh, that's weird. There we go. So now we have the more standard view once you have files in for the first time. So I have my file here. You can see I have my one commit that I just made where I created the index.html. I have my branch, just my main branch here. And I can go and let's say I want to add another file. So what do I want to call this one? Let me just JavaScript. Say +2. Say that addition result +2. There we go. Very, very basic JavaScript. Say that I create app.js. I could give additional info if I want to. Otherwise, so again, I made a commit for that. I gave it a commit name, create app.js. And we can see here in my repository overall, I have these two files. And now I have two commits. I still have my one branch because I haven't branched off or anything at this point. But with that, you kind of get the feel of the workflow here. This is kind of the most basic approach to it. And typically people aren't going to be creating and doing their coding in GitHub itself, but just kind of nice to know that you have this option. Sometimes people will make their readmes like on GitHub and of itself. So I think that's what I've mainly seen. Or two, if you have something like that online computer science course that we just saw. I'll show that again briefly. Oh, no, I guess it's fine. Well, yeah. Anyways, sometimes it makes sense to add files in GitHub. Perfectly good. So just good to know. Let's see. So you cannot have spaces in a repo name. It'll get changed to a hyphen if you try and create a repo with a space. Yes, so definitely don't make it, don't fool yourself with that. Don't even bother adding spaces in the first place. Might as well just add the hyphens. If you use the dot shortcut on GitHub to get a browser-based VS Code editor, keep in mind, do not use that in an empty repository. Okay, yeah, definitely good to know. Browser-based VS Code editor. Okay, very nice. Have to play around with that sometime. Let's see. Okay, so I mean, we made our new file. We've seen how we can do that. Let's cover the importance of README files. So we did this a little bit earlier, a little bit more indirectly, just in terms of talking about collaboration and looking through those two different repos. But we can certainly see that, like in my web app here. Oh, let me do, this is the one that was just like straight HTML, CSS, JavaScript. I have one that's a React refactoring of it. There we go. So if we scroll down, this is my README file. So GitHub makes it look all the more beautiful with this formatting and the ability to use images and all sorts of stuff. But I can go into the raw README file here. Well, can I just show it as, let's do raw. Here we go. All right, so this is how the file looks just like on my local machine, or just as pure text. So we can see we have, it's not as, definitely not as colorful, not as vibrant and vivid as we see on GitHub, but that's kind of the magic of the README on GitHub. I mean, let's kind of step back a bit. The overall point of using your README is to communicate about your project to anyone delving into it. GitHub allows you to, and we can see like this works fine ultimately, but it's definitely not as vibrant. It's not as inviting or digestible. GitHub has this beautiful formatting that you can use to make things all the more digestible, approachable, so on and so forth. But even with that, again, as we were talking about before, communication and context is so important. It's not good enough to just have a README. You have to make sure that things are laid out in a logical way. Just think back to English class in high school, what you learned about writing a paper or an essay. All the same things apply. You have to make sure that things read well, that they're laid out logically, so on and so forth. That you're communicating the information that actually matters. Like, I think it's fair to say this is a pretty solid README for what the application is at the very least. So with that, yeah, definitely have your README in place, as we've talked on before. So with that, we saw how to add and manage files in GitHub in and of itself in a repository. Learned a little bit about the README files. And let's just keep on going on. So actually, let me take a drink of water real quick. All this talking. I think I talked a little bit about this on one of my last streams, but I have this big jug of water. Oh, you can barely even, well, I guess being made of glass definitely makes things more translucent. The green screen effect definitely doesn't help. But anyways. Okay. So now jumping into focusing on collaborative work on GitHub. Definite things to know is features such as adding collaborators, branching and merging, pull requests, issues. Last three already talked about in some depth, and project boards. So let's at least talk about showcase a bit with adding collaborators. So hydration is important. Yes, very much so. My roommate tells me I'm addicted to water. He said I drink it every day and I can't function without it. So he always shames me. So with that, talk about collaborators. So jump back into the code base here. I have my little repo here. Now let's say this is a big project that's going to take multiple people to work on it together. Then I'm going to want to, I can add permissions for certain people that I want to be involved with the project in certain ways. So I can go to my repo, I can go to my settings here, go to my collaborators, and well, it's going to have me put in my password and everything. But anyways, I can change I can like add people's GitHub accounts that I want to collaborate with me on this project. I can change their privileges in terms of how they can edit the project, how they can edit the repository, what changes they can make or what they can't make, so on and so forth. So pretty healthy or pretty important stuff when it comes to this sort of thing. So that is basics of collaborators. Branching we already talked about, merging we've talked about. Pull requests we haven't delved in too much at the moment. I'm pretty sure I have a dedicated slide for that. Yeah. So we'll go on pull requests and everything associated with that in just a moment. Issues we've seen. Project boards is actually a feature that I haven't looked very much into, but apparently, GitHub project boards enable the organization and tracking of work using a Kanban style approach. You can create columns to represent stages of work, as in like to do, in progress, done, and manage issues and pull requests accordingly. So again, with collaborators, as we were kind of going through settings, manage access, invite a collaborator, you'll put in their GitHub username and give them the permissions for that you want them to have for that particular repository, and you can just go from there. So I guess there's 3 like roles and permissions that you should know about on GitHub. There's read, write, and admin. Read basically just allows people to view the repository's content, issues, pull requests, and discussions. You can comment on these sorts of things, but cannot make changes to the code base. So basically what everyone has for any particular public code base. You'll have to explicitly add that for a private code base, however. Then for the write role, collaborators can create issues, push changes to branches, and make modifications to the code base. So you have read, you have write, and then you have admins, which have full control over the repository. They can manage settings, which includes adding and removing collaborators, and they can modify code and project settings. So for the proper organization and just project management of a repository, you definitely have to know those things: read, write, admin. Set up the proper structure, and you can get your project going in a very efficient way. GitHub feature discussions. Oh, nice. Let's jump into it. GitHub features discussions. I don't think I've seen this particular web page for it. Let's see. Home for developer communities, ask questions, share ideas, and build connections with each other. All right next to your code. Enables healthy and productive software collaboration. Oh, look at that little thing. Yeah. Okay, nice. Different category. Yeah, it seems kind of similar to issues, but without a particular issue to tackle. Seems more like just general cognizance and questioning on the project as a whole. Just certainly helpful. Yeah, just a dedicated space for conversations. That's great. What a nice page they put together too. Wow. Look at that. They certainly are on top of their game. Yeah, thanks for sharing that, Thinkiverse. Very good resource. So now getting back to the functionality of GitHub, things to know, forking and pulling requests. So this is definitely a major aspect of GitHub. Now we've been kind of talking about some of the um, kind of the accessory features of it past few minutes, but definitely perk up your ears for this. So forking, the process of creating or forking, the process of creating a personal copy of an existing repository, definitely a very big. I don't want to approach. I'm just trying to think how to articulate this. Let's start from the beginning. So, forking and pull requests. Forking and pull requests, essential collaborative features in GitHub, which facilitate the open source development process and just really any sort of collaboration as a whole. They allow users to contribute to existing repositories, suggest changes, and maintain a structured review and merge workflow. So forking is the process of creating a personal copy of an existing repository. When you fork a repository, you duplicate it in your GitHub account and you gain full control over the copy, allowing you to make changes, add code, and even make it a part of your own project. So forking has all sorts of uses. One of the ones that we were talking about before was open source. It enables external contributors to suggest changes without needing write access to the original repository. So again, it kind of goes back to the access thing that we were talking about a few minutes ago, right? Access, write, or read, write, admin. You can copy someone else's repository for your own use and have write access to it. It's pretty powerful stuff. For collaboration, again, you can team members or collaborators on a particular project can fork a repository to work on features, bug fixes, or experiments. Again, it's basically the same as branching, if you think about it. And forking can also be used to create a customized version of an existing project to meet specific requirements or preferences. So let's go ahead and fork a repository. Kind of jump right into that. And we'll go in on my account. Let's find a random one to fork. Again, we kind of see how we have these different, oops. I want to go to the, where's my, why not just here? Wish they had the nice little repository search. Here, explore. Here we go. Oh, drives me crazy how things change around like that. Anyways, we can go to, let's see what's trending. And the most random things. Private GPT. Interact with the documents using the power of ChatGPT 100% privately. Okay, so let's say, cool, this is a nice, awesome project. Let's say I want to make my own changes to it or, just copy the repository for whatever reason. I can go ahead and fork it. Fork your own copy of this particular repository and click that. I can change the name of it, the description, blah, blah. So you have different options overall. But at the end of the day, we are just forking this. So you can see it's working its magic. Now on my account, I have my own fork of this repository. You can even see here, forked from that original repository there. So what I can do now is I can download, or I don't have to. I can just jump to this code right away and I can start changing things if I really wanted to. I can go on to any particular file. You can see I can edit it here. I can boop, 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 do whatever I want. Because again, it's my own copy of it that I can change and change how I see fit. If there's a particular feature, anything that I want to contribute to it, whatever I want to do with it, I have the ability to do that now. But again, people usually do not do in-depth coding on GitHub itself. They will usually download the code base here onto their local machine and edit the code like in their code editor. And once they do that, they push it on, merge it, blah, blah, blah. We'll see that in detail in just a moment. But yeah, thanks for joining us, Thinkverse. Have a good evening. Issues with GitHub and Codespace. You can definitely check out the MLH Discord as well. I'm sure people would be happy to help you. But with that, we'll kind of see how Git interfaces with all this soon too. A very, very big aspect of using GitHub is using Git. I think most people would argue. But anyways, that's the basics of forking. It's really as easy as that. Just go into a repository that you want to fork, click the fork button, make any changes that you want to the name or description, or if there's any particular branches that you want to fork, you can specify those. And it's easy as that, as you can see here. So with that, what to know after we have forking in place is we definitely want to delve into pull requests in more detail. So we talked a little bit about pull requests earlier. A pull request, in essence, is a proposal to merge changes from one repository into another. From the initial repository, we call it the source branch. So say you have your one repository, like say you forked a repository, and say you want to merge those changes that you've made in your forked one to the original repository. Pull requests are kind of your means of doing that. So pull requests are used to facilitate code review and discussion before changes are merged into the main branch. So let's go over how we make a pull request. So first thing that you want to do is fork your repository. So before creating a pull request, you typically fork the repository you want to contribute to, as we just saw, because that creates a copy of the repository in your GitHub account. And afterwards, you want to clone your forked repository to your local development environment using Git. So basically all that means is you want to copy the code onto your computer so you can edit the code in your code editor. And there's actually a Git command that you want to use for that. Well, I guess I can, yeah, we can go over this. This is fine. Let me pull up my my Git bash. Documents. Let's see. H. I'm going to show you guys how to do a pull request. So if I have, let's see if I can share this. If I have share screen. And I have my Git bash here. So basically what I'm going to do overall is, so yes, Git bash. So this is the command line interface that I use. So I'm on a Windows machine, but kind of a bit of a world to this, you could say. But when you want to utilize Git, a lot of people will do it through their command line interface. So Windows has like the command prompt and pretty sure also PowerShell, if those ring a bell. It's basically like this it's your command line interface is this textual interface where you can interact with your computer by typing text commands. So like here, I wanted to see, okay, well right now I'm in my folder documents, web dev, major league hacking, global hack week. My web dev folder is just where I keep a lot of my programming stuff, but I'm in this particular folder and I want to communicate my folder to my computer to do particular things. So I want to see like everything that's listed. I want to see all the different files and directories within this folder. So I can type like this command here. It'll show me, I just have the one folder called first project. So we can use this to communicate with GitHub to get the code from that forked repository onto my computer. So that's exactly what we're going to do here. So let's just kind of see, again, let's kind of go over the steps that we want to take. So we forked the repository. Now we want to clone the forked repository. So what we'll do for that is, well, let's get back on. Oh, I wish you could have, again, I can only really share one thing at a time on my screen in terms of like sharing my screen. But let's get into this repository again. So I forked this repository and I have this here. Now I want to get this code onto my computer, onto my local machine, so that I can actually make some changes to the code base and the like. So what I can do is I can go to this code here. I have to copy the code, we call it. So I'm going to go to this code here. There's a few things that you can do. You can just download the zip file. It doesn't really create a relationship with GitHub though if you do it that way. You can use a GitHub desktop, which is like a GitHub like interface GUI sort of computer application, which we'll talk about in a little bit. Or you can just use the command line interface, which is definitely the most popular option as far as I'm aware of. At least everyone that I've talked to, all resources that I've seen online, basically everyone does it this way. So, okay, interesting. I usually do it this way, where I get the URL here, copy it, and now I have this URL that points to this repository. So what we can do is we can tell the command line, hey, I want you to copy the code from this URL onto my computer. So it'll take all this code and it'll put it onto my computer. So I copy that, and we will switch to the, we'll switch to my command line. So we can see here. And the way that you'll do this is there's a few different particular commands that'll definitely be helpful to know. One is the one that we want here is you want to say, okay, I'm going to use Git, which is we haven't gone into too much detail on Git yet today, but Git is essentially the tool that will allow you to do all the version control tracking of your project. Like if you remember the commits and everything that we made earlier, that take the snapshot of your code as you develop it with little context, comments and the like. Git is at the heart of that. There's a few things that you have to do. You have to install Git for your project, so on and so forth. But that's more in the realm of Git as a tool in and of itself. Git and GitHub are, at the end of the day, distinct, separate things, though they are very, very much intertwined. This isn't a Git tutorial in and of itself, so I'm not going to go too heavily into the Git details, but you'll see how it can be used to interface with GitHub. So here I say, okay, computer, I want to do Git. I'm going to want to utilize Git. I'm going to do Git clone. To basically what that says is I'm going to copy the files from a repository onto my local machine, and I'm going to do that with from this URL here. So it should, yep, see how it says cloning this private GPT, cloning that forked repository that I had, and here it is downloading everything. Now if I say, okay, list me all my different folders that I have here. We see before I only had this one project here, but now if I ask it to list again, it's going to have a folder for this forked repository. Now I can go inside of this folder. CD means change directory. We're just going to go inside this folder that we just downloaded the code for. Now I can show, so now I'm inside of it here. Again, this is just the code from that forked repository. I can say, okay, show me everything that's inside this folder. And we can see everything that we saw on the repository is here. So let's just kind of take a quick mental note of this stuff. Like there's a change log, there's a docs folder, local data, models, private GPT folder. If we switch over to online repository again, we'll see we have exactly that stuff. So let's do here. So here we have that docs folder, that local data folder, models, private GPT, right? Everything is there that we because all we did was that we copied the files to our local machine, to our computer here. So now what we can do is we can open this project up in our code editor, and we can make the changes that we want, and we can then incorporate those changes into our Git repository. And once those changes are in our Git repository, then we can merge those changes into the original project, right? The one that was forked. Now we're not going to go that far just because I don't have anything meaningful to add to this at the moment, but we'll at least kind of get right up to before then. That way you can see how the workflow typically goes. So we can see Git is version control. That is version control tool. GitHub is just a storage container. Yeah, exactly. It's the way to, in essence, that's how everyone uses it, right? You store it online so you can easily share, collaborate, so on and so forth. And yeah, Git is the key to using GitHub. Very, very true. Yeah, so that's the thing. Like, you can't really talk about GitHub without talking about Git. I mean, it's in the name, right? It's the hub for Git. It's the hub for Git projects. It's just a means for sharing Git projects. What is .git ignore for? Very good question. We can unpack it a little bit here. So basically, oops, takes a little bit of work to balance showing multiple things on screen, like going back and forth between them, but here. So your .git ignore file, actually, that'd probably make more sense if I open up my code editor. So here's a really good little tip for you guys. If you type in code whatever your current folder that you're in, like here I'm in the folder for the for this repository that not the repository itself, but the directory that I downloaded. Do code press enter, it'll boot up VS Code in that directory. So it just opened immediately, but I'm gonna have to shift things around for a second so I can share my screen on my VS Code. But yes, let's go into, so what is git ignore for? So let's go to window. Here's my VS Code. Okay, so .git ignore. So basically, when you're working on any sort of project, right? Imagine like when this project was very first put together, there was basically nothing here, no files, nothing of the sort. Then remember that whenever you make changes to your project code base, you want to take a little snapshot of it, tracking your project at meaningful points. So you don't really ever want to go from completely blank project to completely finished project, because there's a million different points along that pathway where you probably should have made some commits, taken some little snapshots to keep track of the history of the project, and at the very least to give context to other developers that are hopping in, but also to just kind of safeguard your development and time and so on and so forth. So anyways, you're developing this project, you're adding new files, making changes to some of those files. What your git.ignore file does is it tells Git on your computer, hey, there are certain files that I want you to ignore when changes happen to them, and I don't want you to ultimately contribute them to the repository that's going to be put up on GitHub. Kind of a simplistic explanation of it, but that's kind of gets the idea across. There's certain files that are just not crucial to have on your repository on GitHub, for example. Or sometimes there's files that you don't want to be put onto your GitHub repository. Say you have some like access keys, or you have some security information that you don't want to share publicly, or you don't want those to be included in your Git project to then put onto GitHub for the world to see. What you would do is you would include that file, whatever it is that you don't want to be shared, in this .gitignore file, because that'll tell Git, hey, don't keep track of this file, don't keep tabs on it, don't put it don't put it as part of my repository once I finally push it into GitHub, for whatever reason that may be. And yes, exactly. So it is a file with components inside that Git will ignore to use. So yeah, it really just depends on the context of what it is that you're making. A really good example is, again, like if there's any sort of personal credentials or access keys or anything of the like, you don't want to share those with people. If you are API keys are another example. There's sometimes, maybe it's an API key that you bought or that you don't want the public to have access to. You most likely want to ignore that as well, so that you aren't sharing it with the public. Some files are just kind of redundant to include. Like I think this DS Mac, what is this? This DS store. I think that's just like a generic Mac file. That doesn't really do anything, as far as I know. I mean, I've never used Mac before, or at least I've never owned a Mac device. So I know it's just usually not the most crucial of things. So you'll often see that included in your .gitignore. So on and so forth. What if you have access keys in a file? How do you indicate that whoever clones the repo that they need to make their own file, even though you're not uploading yours? I think documentation will usually handle that. Like, I know that, for example, if I remember right, the MLH Fellowship, they'll do projects with like a web API that tells the weather. And you need a particular API key for it, but you don't want to put that key online because it's not for the public to use or to utilize. So you can tell people, hey, if you want to use this functionality on this repo that we've made, you have to get your own API. So you can even give them the website on where they can get their own API key in order to utilize the website, so on and so forth. So there's always ways to communicate things like that. Again, as we talked about before, that's where like a good README comes in. How do they know what the contents of the file should look like? I'm sure that is just contextual on the I would imagine it's contextual. Like maybe there's a particular file that they can download that over all the formatting and everything is already in place. So you can just tell them, hey, just download this file, stick it in this folder, and you're good to go. Or two, maybe they have to like, let's see if we can do like a quick little example. I don't know, we can just call it something like that. Even do something like that. You can say here, this is the general formatting for it. Like API key, it goes here. People will even, I don't know, there's lots of different ways. It's more about like, how do you communicate it more than anything. I don't think there's like an exact standard. Exactly. It all kind of comes down to documentation. Everything in this life is contextual. How certain projects are going to handle certain things compared to others, it's all contextual. It can be completely different. There's not like a one answer for that on how to do that. But it is a good question though. Okay, Docker, no. Nope. Can we trust it's secure to store such info and it won't be hacked? As in, can you trust your gitignore file? in order to do that. Git ignore files are very standard for this sort of thing. Because it just doesn't put the file online. So someone would have to hack into your local machine and grab that file if they want to. Otherwise, there's no way for like GitHub to know about the file if it's if it's not uploaded in the first place. So with that, okay, perfect. Yes, yeah, I know it is. This kind of a concept in and of itself, the git ignore file, but definitely a mainstay in terms of developing projects for Git and GitHub as a whole. It's a long game for hackers to hack. Yes, definitely quite the activity, it seems like. But anyway, so talked about forking, pull requests. We saw we could copy the code down. We can go a bit into how to edit the code. Let me just see what else I've got coming up. GitHub desktop. Not the craziest things. I mean, things that are good to know about. There is GitHub desktop, graphical user interface application provided by GitHub for simplifying the use of Git and GitHub for version control and collaborative development. So basically, if you like a more visual approach than the command line, GitHub desktop is perfectly good. I think everyone that I know at least uses the command line for GitHub, however, because the command line is just an essential tool for software developers. But you can check out GitHub desktop. Definitely wouldn't hurt. Might resonate with you more at the end of the day. GitHub related tools we can go over. Git command line. So yes, this is where we start getting into the basics of Git. In fact, that might help before we delve more into. That would probably be a little bit better to cover before we go deep into the like forking and making changes and then pushing to GitHub. So let's see, if you accidentally upload a confidential file, in repos, editing a file to ignore, remove any record of ever existing. No, so you can actually delete commits in your repo. So you can do that. So here, let me show you. I'll give you an example. That is a good question because, like, you know, sometimes people make mistakes, or it doesn't even have to be if it's a confidential file or the like just say that you've made a commit when you didn't mean to, or so on and so forth. If there's any reason as to why you have to delete a commit, you definitely have the ability to do so. So you can do it either on your local machine, or you can also do it on GitHub. Let's look at it on GitHub for a second. So we can see that I have this little repo that I made earlier. It has 2 commits currently. If for whatever reason, there's one that I just am not crazy about or that I need to delete for whatever reason, there is the option to do so. I've actually never done it on GitHub before. Curious where you would go for that. It's actually a little bit of a process on Git itself, but I know that it's definitely an option. Just don't know how to do it off the top of my head when it comes to GitHub. But yeah, it is an option. Well, I'm surprised there's no readily accessible way to do it. Anyways, let's see. Okay, we can delve a little bit into Git. We don't have too much time left as of right now, but I think going over the basics of Git would be helpful. So again, like we just saw our first instance of GitHub and Git coming together, right? We saw that we could copy the code from the repository onto our local machine, and then we can open it up in our code editor and make particular changes. So let's kind of start from the beginning with Git. So I'm going to be doing a bunch of screen juggling. So I can only set up one thing to screen share at a time. So just give me 1 second to get this going. So I have, so let's look at here. So you need to, so you have to install Git. You can just, not going to go into detail on that. It's easy enough. You also have to, so once you have Git installed, then you can actually start using it. So how it's going to go is we're going to make a project on our computer and we're going to initialize it with Git. We're basically going to say to the project, to our computer as a whole, hey, for this project that we're developing, I want to be able to use Git features and version control and all of that. Everything that Git has to offer, I want to be able to utilize it in this project. So it's going to give us access to that, and then we can see our basic commands that we'll have with it. So with that being said, let's do this. So I'm going to make a folder on my computer for a new project. Let's say new project. We can call it, let's say, like a website project. We can just call it that. Let's do this. Okay. So I'm going to make this here. I can see make directory, which basically is going to make a new folder called website project. So imagine this is a website that I'm developing. I'm going to go into that folder. So here I'm inside this website project folder. And again, let's imagine I'm making a website from the ground up, completely from scratch. So there's nothing to pull from GitHub or anything. I'm making a software development project on my computer from the very start. So I made my folder where to keep everything. Now I'm going to tell my computer, hey, I want to be able to use Git functionality in here. We do that by saying git init after I've already installed Git and everything on my computer. So with this in place, I have access to Git commands, which we'll see in a moment. If I type git status, it's giving me an error, which means that maybe Git isn't functioning on this project for whatever reason. Instead, it tells me you're on the master branch, which is your main branch. You have no commits or anything, blah, blah, blah. So everything's good. So it's recognizing that Git is here. Git is able to be used in this project. So, but this is just an empty folder right now. I haven't done anything with it. But if I say list everything within this folder, there's nothing to list. So let's get started on my project. So let's say I'm going to create an HTML file, a CSS file, and a JavaScript file. Now I can see I have, if I list everything here, I can see I have those 3 files. So now remember that Git is a version control software. It is going to be tracking changes to the code base. So we just had a change, right? We added these 3 files. So if I say Git, what's the status of my project? Has anything changed? Say yes, you have these 3 files that I detected a change for. The change being that they're new files, right? They weren't here before. So if I want to take a snapshot of the project now, I want to say, hey, I want to, it's just our commits. If we want to do a git commit, if we want to take a snapshot and say, hey, something about our project changed, let's put a little marker here so that we can come back to it or so that we can get context on it, whatever the case is. The way that you do that is you do git add, and you add any relevant files that you've made changes to that you want to make a commit for. So here I have all my files here. I could list them all out individually like this, or if I just want to add all my files, I could just do this dot. So it's going to, by doing this, it's going to tell my computer, hey, I'm going to get ready to make a commit. It's not going to make a commit yet. It's not going to make that little snapshot yet. Instead, it's like, best way to think about it is that we're getting everyone around for the picture right now before we take the snapshot. Like, hey, everyone gather around. So I want my app.css file, my app.js, and my index.html file. All you guys, you're all going to be in the picture together. So everyone's getting in line to get your picture taken. So we can get our snapshot here. And now everyone's gathered around. I can say git status. It says, okay, so these files are ready to be committed. These changes that have been made, we're going to take a snapshot of them. So I can say, okay, git commit. And I can do -m, which is going to let me make a little comment about what's going on, give some context to it. And say create init. This is the initial state of my project, right? There's nothing crazy going on. So just a bit of an overview. Again, we we made this project. I made the folder for this project to be. I made the folder for it. I initialized the folder to be a Git project. So I'm telling my computer, hey, I want to be able to do Git things like Git add, Git commit, Git status, so on and so forth. So we said Git status just to verify that Git was indeed working. We saw there's nothing in the project folder. So no changes to the project or anything yet. But now I do make a change, right? I create these 3 files. When you see that they're in my project folder now, and since I made these 3 files, I'm going to see if Git has detected that as well. It indeed has detected that. So Git can see that I have made a change to my code base. And so now I want to make a commit. I want to keep track of this. So I say, okay, let's take a snapshot of this. So everyone gather around that wants to be in the snapshot. It's going to be these 3 files. And I added them around. Now I'm going to take that snapshot with the Git commit. I'm going to give some context as to why I did it, or what exactly is going on with it. So here we go. So now, if I say Git status again, I just made a commit. So from the last commit to now, there's no changes because I just made my commit. So nothing's going to show up. Let me see. Git. So I use Git help to see what I can do here. So we can do Git log. That's it. I forgot the exact term for it. So Git log shows that I made a particular commit at this time, at this date, by me, blah blah blah. So it kind of just keeps going from there. Like, say I want to let's see. I do like, wait. Oh, I'm not sure if there's a clear because it's kind of getting messy now. Anyways, let me keep up with the chat. Okay, in-depth discussion on security in Git. But hello, Tintin. This session is intro to GitHub. So it's all about GitHub, learning the basics of it. Now, GitHub is the website that is, as in the name, is the hub of Git. It's the hub of code bases as tracked by the version control software Git. So now we're just going over some basics of Git. We covered quite a lot of good things today. We're actually coming towards the end now. We're about near the end of the hour, but I guess we can try and show a little basic push to a repository. Well, basically, anyways. So we made that change. We can make another change. So I'm going to open this up in my code editor. You can see here. Let me share screen again. Oh, presents, share screen. Let's get my VS Code up. So now I can make a change in my file here. But I can say, okay, let's say I'm in this index.html. I say, here is an addition to code, whatever it is that I want to say. I can save it. Now, if I go back to Git, if I go back to the command line, and I ask Git, hey, has a change been made? It's going to say, yes, there's a change been made in my index.html file. And that's, you can just leave it at there. I can go on to make other changes in my file. So if I say Git status, it says, hey, there's a change in your index.html. And so I can go, okay, well, I can just keep on developing other things if I want. Like, say I haven't made enough meaningful changes yet to make a Git commit. You don't need to do it for every tiny little thing. But let's pretend that this was good enough to make a commit for. We can say, okay, we'll git add, and I'll do my index. Or since it's just one file, I could also do the dot. It would just grab everything. This is fine though. You could say get status if I just want to check. You don't have to do get status every time, but it'll show you. Okay, so I have the index.html that I'm ready to take a little snapshot of, and I'm ready to commit. Say add HTML, something along those lines. Okay, so now I can see my git log. If I were to do it, I'd have both my things. So with that, you just essentially keep doing this. You develop your project, keep making changes to it. Once you're ready to put it onto GitHub, then you can go and make a repository for it. So let's see how to do that really quickly. I guess we're getting kind of close to the end of the hour here. Essentially what I can do, I can get here. I have this repository. I can make a new repository for it if I wanted to. Grab the link for it, and then I can go into Git, and I can say, hey, Git, here's a repository on GitHub that I want you to push all this code to that I developed. Go ahead and do that, and then I'll upload the code from my local machine onto GitHub. And you can just have a back and forth from there with your GitHub, with Git and your Git repo for the project. So, kind of near the end of the hour. I don't think I'll have much time to show the full process for that, but at the very least, I think we covered quite a lot with both GitHub and enough of the details of Git to at least get started, kind of put you in the right direction. Are there any questions or anything of the sort as of right now? I know we had sort of stuff I wasn't too crazy about in terms of like having to absolutely cover it. I think we covered quite a good amount of practical things. So yeah, if anyone has any questions or anything of the sort, definitely let us hear them. Okay, let's see. Basic, seems like you guys are talking about security with Git and the like. So we were talking about where's that at? Like, is Git secure to upload files and deal with potentially sensitive data with? So there looks like, yeah, outlines quite a few helpful things. So use encryption tools to protect secrets, only decrypt when needed, allow permissions. Definitely good stuff for anyone interested in security, cybersecurity, and anything in that of that nature. Ooh. This is certainly stuff I have not delved into myself, but I love that you guys are delving into it. Okay, sweet. Git rebase. A good question. I use Git rebase myself, from what I recall at the very least. At least from what I'm Googling here. Git rebase looks like there's official docs for it. We can jump into that. Just found these. About Git rebase. Allows you to easily change a series of commits, modifying the history of your repository. You can reorder, edit, or squash commits together. To edit previous commit messages, combine multiple commits into one, delete, revert commits that are no longer necessary. Okay, interesting. Yeah, I haven't been in any situations myself personally where I've had to use rebase, but I haven't worked on like any too complex, large-scale projects. I've usually just done stuff for like smaller internships and the like. So, pretty interesting. Okay, so we are at the end of the hour here. I'm going to go hop off now, but thank you all for joining me today. I hope this was helpful, gave you some insight into GitHub and Git as a whole. Stay tuned for the next event. Have a good rest of your day, guys.